This is Unit 4, Syllabus 1, which is the development of the periodic table. This talks mainly about the important people of the unit and their ideas about how the periodic table should look and what's the components of the periodic table. All information found in this video are from Chapter 6 in the McGraw-Hill book, where if more information is needed, it goes more in depth and talks further about the people and their ideas. The first person is Antoine Lavoisier. He was a French scientist that lived from 1743 to 1794. He composed a list of all the elements that were known at the time, which was 33 elements. These were organized into 4 categories, which were gases, metals, nonmetals, and earths. He also did work with the conservation of mass and helped with the idea of basing chemicals on their properties. The top picture is a picture of him, and the bottom is a table of simple substances where it shows the 4 areas he separated the elements into, which were gases, metals, nonmetals, and earths. And it gives examples of what he thought were in it, like light and heat for gases, and in metals were silver and arsenic, nonmetals were sulfur and phosphorus, and earths were chalk and magnesia. The next person is John Newlands. He's an English chemist that lived from 1837 to 1898. He proposed a way to organize elements. He noticed that if elements were arranged by increasing atomic mass, their properties repeated every 8th element. He named this the law of octaves. This idea was hampered and denied because it didn't work for all the known elements at the time, and his scientific peers did not like the unscientific word octaves, which he got from the musical concept. He was later found out to be partially correct because the element's properties do repeat in a periodic way. It is just not the exact way he thought they did. The picture to the left is a picture of him, and the picture to the right is a physical example of how the law of octaves would look, where you have the 8 elements and the elements with similar properties are in the same row. The next person is Lothar Meyer. He's a German chemist who lived from 1830 to 1895. He demonstrated a connection between atomic mass and the properties of elements. He and Mendeleev came to similar conclusions at similar times, but because Mendeleev published his original ideas first, he is often given more credit. An important way to distinguish Meyer and Mendeleev is that Meyer was a German chemist and Mendeleev was a Russian chemist. The picture is a picture of him, and a fun fact is his first name is Julius, but he has never used his first name throughout his whole entire life. He was always known as Lothar Meyer instead of Julius Lothar Meyer. The next person is Dmitry Mendeleev. He is a Russian chemist who lived from 1834 to 1907. He noticed that when elements were put in order by increasing atomic mass, they had a periodic properties pattern. He created a periodic table where he organized the elements in columns by their shared properties and increasing atomic mass. This table became accepted because he predicted the existence of elements and properties that were found later. He left spaces where he felt unknown elements should go. The picture to the right is a picture of him, and the picture to the left is his periodic table, where you can see the blank spaces where he knew there were elements, but he didn't know what the elements were or their properties or anything about them. Next person is Henry Moseley. He's an English chemist who lived from 1887 to 1915. Mendeleev's table was not completely correct, and several elements were not in the correct place on the table, and Moseley knew how to fix that. He realized that by arranging the elements in order of increasing atomic number, that the problems with the order of the elements in the periodic table were solved. The picture is a picture of him, and a fun fact is the gaps that Moseley recognized existed on the periodic table in Mendeleev's table had nothing known about them at the time, even their existence. So the elements that they knew were missing, they didn't know what they were or anything about them. He introduced the idea of periodic law. That is the statement that there is a periodic repetition of chemical properties of the elements where they are arranged by increasing atomic number. So the key people and key ideas of the people. Antoine Lavoisier is from 1743 to 1794. So he is a decent bit before everybody else. He's in the 1700s, while everyone else important is in the 1800s. He composed a list of elements known at the time, which were 33 elements, and he put that list into four categories, which were metals, nonmetals, gases, and earths. John Newlands was from 1837 to 1898. He arranged elements by increasing atomic mass, and he noticed a repetition of properties every eighth element, which was the law of octaves. Lothar Meyer, 1830 to 1895, he demonstrated the connection between atomic mass and elements properties, and he arranged elements in order of increasing atomic mass. Dmitri Mendeleev was from 1834 to 1907. He demonstrated a connection between atomic mass and elements properties. He arranged elements in order of increasing atomic mass, and he predicted the existence of properties of undiscovered elements. Once again, a good way to differentiate Meyer and Mendeleev, since they had very similar ideas at very similar times, is that Meyer is a German chemist and Mendeleev is a Russian chemist. Henry Moseley was from 1887 to 1915. He discovered atoms contain a unique number of protons called atomic number, and he arranged elements in order of increasing atomic number, which resulted in the periodic pattern of properties. The key ideas were one is the law of octaves, which is if elements are arranged by increasing atomic mass, their properties repeat every eighth element. This idea, once again, was not accepted at the time because there were a lot of elements that were unknown, and because of what his peers viewed as informal and unscientific word of octaves. Another key idea is the periodic law, which is periodic repetition of chemical properties when elements are arranged by increasing atomic number. Important charts to remember, or just ways to help you remember the ideas, is the picture on the right is the law of octaves, where you show the 8 elements and then how the elements with similar properties are in the same row. The picture on the left is Mendeleev's table, which is an important concept because he helped set a lot of ideas for our current periodic table, and it also showed his idea of knowing that more elements existed, but not knowing where they would go exactly, since he was incorrect in some of the placements, and the idea of not knowing their properties.